Okay, so we have binary multiplication with logic gates. So I've got inputs here, just the same as normal, and I've got a vertical compact AND gate. I'm pretty sure this is the most compact I can get it, and an output just so we can copy and paste it. But first we need to hook up the first stage. So what you need to do first is multiply every bit with every bit, just like in a normal multiplication. You have like a timesing table, I forgot what they're called, and you put like your tens, your hundreds, your tens, your units by 110 units, and you multiply every single bit of deanery. You do the same with binary. So what I'm going to do is going to check for every bit. So I'm just going to copy and paste 16 of these because there's 16 combinations for this. Okay, so I've got 16 of these. So what I think the best way of hooking these up is to do it like this. So hook the first bit of the first number up to these ones, then hook this one up like this, and then hook this one up like this. So there we are. So we've got the first number one inputs connected to the AND gates, and then now we need to do the number two bit ones. So we're gonna connect this one, then we're going to skip 4 to go to this one, skip 4, go to this one, skip 4 to go to this one. So bit 2 we start 1 ahead of the previous, so then you just carry on skipping 4. Okay, so I've hooked all them up. So this is going to do check for every combination. So if this is on and then this is on, then this one's gonna multiply. Oh no, that's the same number. Derp. So if I do this one, then this one will go to this AND gate, and this one will go to this AND gate. So the output would be here on. So I'm just gonna turn these off now. So the next stage is to order them because this is gonna be 1 times 1. It's gonna be output for this. That's gonna be 1 times 2, 1 times 4, 1 times 8, and then it'll be 2 times 1, 2 times 2, 2 times 4, 2 times 8, and it's going to be a pattern like that. So I've labelled all these things, the output which they'll give, and you notice there are 4 8s, there are 3 4s and 16s, there are 2 2s and 32s, and there's 1 1 and 64. So now we just need to collect all the common terms, but we need to order them into the right order. So 1 at this end and 64 at this end. But I need to hook them up to AND gates. And on this program, I can't actually just do that and leave it there. So I'm just going to have to hook them up to the AND gates. Actually, the 1 can go directly to the output. So I'm just going to copy and paste this, and hopefully that's in line. That's a fair attempt. Come on, be in line. Yeah. Okay, so the 1's done. The 1's straight out, but so the 2 needs to be collected together. So now I'm going to get the adder and put it about here. I've got to leave room for some busing to get these in the right order. So you might move it up a bit. Okay, so this adds to this, and then you add the 2 to the 2. I don't know where to put the crossovers. So that's pretty simple. Next, we need to collect the 4s. So I need to give room for. No, I don't. I can put that there. So the 4s need to be collected together. So I'm going to do this and connect that one and connect this one to here. And notice there are 3 4s. So what we need to do is have a carry out and go into the next one. So what we need to do is add the 4 to the output of the previous. So get this 4 and bus it like this. Just try and get enough room and hook it into this adder. So now it's added the 4 and the 4, and the output of that's been added to the next 4. So we connected this carry out into this one to add this up, and now we added this into this. So now we need to collect the 8s. So this is going to be the biggest one. So I'm going to do that and bridge over there. And so get the first 8 like so. And then the second 8 is going to connect to there. And then we need to get the output of this 8 and add it into there. That carries into that. And this adds here. And this 8 needs to come fairly close to this. And connect to there. And the output from this 8, actually we don't, oh we do need that actually. So then that output goes into there, then we get the fourth 8 and try and make this as compact as I can. Needs to go up here and connect to this one. So that's added the 8s. So that's the most complicated one, so there's 3 adders. Okay, next we need to collect these 16s. So I'm just going to put this here and carry this over. So 16, here's the first 16, there should be 3 in total. 16, 16, and 16, then we need to add the next 16. And then have the carry out going into that. The carry in, I guess I should say. Put that there, and connect that up. Okay, now we need to connect the 32, so there's only 2, so we only need 1 adder. So handle the carry in. So 32 is going to go here, and then into that, and then this 32 goes up to that one. I'm just going to leave this like this for now, and then we need to add the 64 to the carry in. But every one of these needs to be handled with the carry in. Everything left, of the 8 needs to have an adder to handle the carry out in. So this is just going to go into here, and it doesn't actually need this line here, but it doesn't really matter. I'm just going to leave it in for the rest. So we need to handle this, so we're going to add this into here, and again you can delete this, but I'm not going to do it for all of them. This needs to get handled into this. This goes in there, and that. This is just to handle the carry outs. So that goes into there, and that goes into there, and then the 64 needs to go into these as well, and then one more. Okay, and notice we've got this carry out, because if you multiply two 4-bit numbers, you can actually get 120. You get 255, which cannot be stored in 64. So if you had a 128, which is what we are going to have, then that's good. So I'm just going to move this up if it will let me. And the outputs for these are all done now, so I can just copy and paste this. So I've got an extra one here for the 128, so I'm just going to hook all these up, and then what you do, you just hook this up and then connect all of these. So if at any point there is a carry out, and it could occur at any of the stages, then it will go into the 128 output. And I guess you could hook this up to an OR gate, even though there's no real need. Okay, so let's test it. Okay, let's do 12 times 13. That's going to be quite interesting. That should be 156, I think. So 12, the first number is going to be 12. Let's click play mode. So 12 will be, we'll need an 8. Then it'll be a 4. And that's it. 13 will be 8, a 4, and a 1. So then we should have, and this is dim because we didn't put it up for an OR gate, but it still works. So that was 156 it was. So this is the 1s, the 2s, the 4, plus 8 is 12, plus 16, wait, it was 12 plus 16 is 28, plus 128, which is right.